Okay, so again, we're focusing on this whole chapter is all about the periodic table. So the last chapter is about electrons and atoms. Now we're going to focus on the periodic table, and you're going to do the readings and such for all of the different characteristics of each group and family. Again, which is kind of a review. We went over this. Remember when we color coded our periodic table, but you're going to kind of reaffirm it in the beginning part of the chapter through the readings. But we're going to start with periodic trends. And the first trend we're going to talk about is atomic radius. So, okay, radius, like in math, is you have a circle, right? And you have the middle of the circle out to the end of the circle. That's your radius, right? So when we do it in this chapter, we're talking about atomic radius. We're going to talk about it in terms of an atom because we're focusing on like elements. So if you have like an atom, and we'll pretend it's like the Bohr model, you have your nucleus in the center, and then to your outermost electrons, the furthest place away you find electrons. Maybe it's in the third ring, fourth ring, fifth ring, sixth ring, whatever it may be. So the bigger the radius, the bigger the atom, right? If you had a radius like this compared to a radius like this is a bigger radius, which means this would be a bigger atom. This should make sense visually, right? Smaller radius makes something smaller, okay? So now we're going to talk about trends in the periodic table. Trends, again, they're like patterns, okay? What are we going to notice about the radius as we move around in the periodic table? So there are going to be some new fancy words that you need to know, okay? We're going to talk about period trends. This means left to right or right to left, okay? Remember, period is a row. So if I go back to my periodic table, so this is like the first period, this is the second period, this is the third period, this is the fourth period, and so forth. Okay. So, and then group trends, we're going to talk about group trends. These are your columns, top to bottom or bottom to top. Group, so these are your families, like your alkali metal family. Family. Okay. So we're going to talk about the period trend first. We're going to move left to right on the periodic table. So we're going to go across a period as you go left to right. So if you look at, in this example, this is period 2. So period 2, you have lithium, beryllium, boron, carbon. So you go to your periodic table. So we're focusing on, oops. So look, lithium, wait, why did I do that? So lithium, beryllium, boron, carbon. These are all period 2 elements, okay? And we're going to go left to right, all right? And technically we'd go all the way across. So the periodic trend is as you move left to right on the periodic table, the atomic radius, the radius of the atom, gets smaller, decreases. As you go left to right, the radius decreases, and you go, well, this is kind of confusing. So you go, okay, well, why? Well, and as you move across a period, the number of rings you have does not change. So, right, we're using the Bohr model of the atom, which is not the best model, but it still works for conceptual stuff. Okay, so all of these atoms have 2 rings. So they don't end up with more rings of electrons. So that's not going to be a factor. The difference is that lithium has 3 protons in its nucleus. Beryllium has 4 protons in its nucleus. Boron has 5 protons in its nucleus. Carbon has 6 protons in its nucleus. So what happens is the more and more protons you get in the nucleus, more protons, the more what's called effective nuclear charge. That's also called Zeph. This Z stands for nuclear charge. and then that F means effective nuclear charge. So what does this whole fancy term mean? Well, what keeps electrons attached to an atom? Does anybody know? Why don't electrons fly off the atom? What keeps them there? Anybody want to guess? What keeps the electrons in orbitals around the atom? Well, it's the protons, right? Electrons are negatively charged while protons are positively charged. So it's this attraction that keeps the electrons around the atom. Speaking of which, what do the neutrons do? What's the point of the neutrons in the nucleus? They help keep the protons from repelling each other, right? Protons don't like other protons, so they act kind of like as a buffer in between other protons. They keep the protons from flying off the atom because protons don't like to be with other protons. So the neutrons are kind of like this little buffer between the protons and the nucleus. But the nucleus, the protons, which is nucleus is positively charged, right? Because neutrons don't have charge, and then the electrons are negatively charged. So the electrons are attracted to the nucleus of an atom. Well, the more positive charge you get in the nucleus, the more the electrons are attracted to the nucleus. Well, everybody look at me on the screen now. I'm going to share myself on the screen. Where's my videos? Okay, everybody look at me on the screen. Don't look at the PowerPoint. Okay, so if you have an atom like this and it's getting more and more protons and the electrons are more attracted to the protons because the more protons there are, the more electrons will be attracted to it. Well, protons are located in the nucleus, so if the electrons become more and more attracted to it, the electrons will move closer and closer and closer to the nucleus. That's what causes the atom to shrink as you get more protons. So again, the fancy way they word this is called effective nuclear charge. There's more positive charge in the nucleus, which makes the electrons more attracted to the nucleus, and the nucleus is in the center. So if the electrons become more and more attracted to the center, they will move towards the center, effectively shrinking the atom as you go from left to right. So if you go back to your periodic table, this atom would have the largest radius in period 2, and neon would have the smallest radius in period 2 only. Period 2 only. Why? Neon has 10 protons in its nucleus and lithium only has 3. This has way more effective nuclear charge, which means the electrons are more attracted to it, which means the electrons will move in closer to the nucleus. So biggest radius in this period, smallest radius in this period. So we say atomic radius decreases as you move from left to right, which means the opposite. If you would go right to left, it would get bigger. So smaller one way, bigger the opposite way. Okay. So I just want to show you this real quick. So look at, here's my lithium. The biggest radius in its period, and then it gets smaller and smaller and smaller and smaller till it hits neon, which is the smallest in period 2. Okay, and then again, look at period 3. Sodium, and then it gets smaller and smaller and smaller as you move across the period, because all of these guys have 3 rings of electrons in the 3rd period, but this guy has the most protons to pull the electrons closer to it. Protons and electrons attract each other. The more protons you have, the more attracted you are to the nucleus. I see some things in the chat, so I'm going to see if there's any questions. Okay. So now, let's go back to the group trend. Okay, we're going to go back to the group trend. Now, this one is, I think, a little bit easier to understand conceptually, but something I am going to say is contradictory. So a group trend is we're going to work with a family. So in this case, we're going to go down the periodic table. So instead of going across, we're going to go down, down, down. Please note that I am completely ignoring my transition metals. We're not going to pay attention to transition metals for this pattern, okay? We're going to do what are known as the main group elements, which are our S and our P block elements, okay? Down, down. So we're going to do group trends. We're going down now, okay? And we're doing specifically atomic radius. So I'm going to close this and reopen a new one. This trend is probably going to make more sense. Here's why, right? You have hydrogen has 1 proton and 1 ring of electrons, okay? Here's my 1 electron. Lithium has 3 protons, so that means it's in the second period, so it has 2 rings of electrons, and that means it has 3 electrons. Sodium is atomic number 11, so that means it has 11 protons, and if it's neutral, right, 11 electrons. But it's on the third period. 2, 3, 4, 5, 6, 7, 8. Okay, it's on the third period, so it has 3 rings. Okay, and then as you go down, right, you're increasing energy level, aka you're gaining a ring of electrons and then another ring of electrons and another ring of electrons. So it should make sense that as you move down a group or down a family, as you go this way on the periodic table, atomic radius, whoa, why did I do that? Radius increases. The atoms get bigger as you get bigger and bigger and bigger. So conceptually, that's because you're gaining more and more rings of electrons. So if you were to just look at these conceptually, look at the radius. That's the center of the nucleus out to the outermost ring, center to the outermost ring, center to the outermost ring, center to the outermost ring. This is the smallest and this is the biggest of these 3. Okay, here is the issue though. I just taught you, so this guy has 1 proton in its nucleus, this guy has 3 protons in its nucleus, and this guy has 11 protons in its nucleus. I just taught you that the more protons in the nucleus, more protons is more effective nuclear charge. I just taught you that on the last slide. Meaning the more protons you have, the more attracted the electrons are to the nucleus. Here's the problem with these though. So I'll redraw my electrons. So this guy has 3 electrons. This guy has 1. This guy has 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Okay. This effective nuclear charge concept works when you have the same number of rings of electrons. Same number of rings, okay? Okay. These guys are gaining rings every time you move down a family. So you go down to another period, you're getting more and more rings of electrons. So you go, okay, yes, this has more protons in the nucleus. And yes, technically this would have more charge in the nucleus. But the outermost electron right here, that's this guy right here, okay? The attraction of these protons is going to be stronger with these inner shell electrons, meaning these inner shell electrons actually kind of block the ability of the nucleus to be able to attract the outermost electrons. And this has a name. It's called the shielding effect, right? A shield would mean like to block you from something. So these electrons right here, like these electrons right here and these electrons are right here, kind of block the ability of this nucleus to attract this outermost electron, because that's where you have to bring the atom in to shrink it. So even though you do have more protons in the nucleus, because you're gaining more and more rings, those inner shell rings and inner shell electrons shield the nucleus but being able to attract those outermost electrons, which is why the radius will still get bigger even though you're gaining more protons in the nucleus. The more rings of electrons you have around the nucleus, the more shielding you have. And the more shielding you have, the less that the radius has the ability to increase. I'm sorry, to decrease. Okay? So again, that's called the shielding effect. So look, as you go down a group, so family number 1, this is our alkali metals plus hydrogen. Hydrogen's not really an alkali metal, but it's here because it has 1 valence electrons. As you go down a group, the atom gets bigger and bigger and bigger and bigger. The radius gets larger. And the radius gets larger because you have more and more rings of electrons shielding the nucleus from being able to shrink the atom. But as you go left to right, the rings of the atom stay the same. It's the protons only, the protons that are increasing, causing more nuclear charge in the atom to shrink. So atomic radius increases as you go down and decreases as you go left to right. Are there any questions about atomic radius? Okay, so I want you to take a moment, and I'm going to pause this. Or actually, I'm going to do A and B with you, and then you're going to do C, D, and E, okay? Which of the following pairs is larger? So magnesium or strontium? So now you're going to need your periodic table, and you're going to have to compare them. So magnesium or strontium? So you go, here's magnesium, here's strontium. Which one has the larger radii? Well, it's gonna, these are in the same family or the same group. So it's gonna be strontium because strontium has more rings of electrons, AKA more shielding effect. So it will be larger. This guy has 5 rings of electrons. Magnesium only has 3 rings of electrons. So watch, magnesium, 1, 2, 3 rings because it's on the 3rd period, right? Strontium has 5, so I'd be like this, 1, 2, 3, 4, 5, right? So this is much larger than magnesium. All right. Let's try another one. Strontium or tin? Go to your periodic table, find strontium, find tin. Okay. So these guys are in the same period, which means this guy has 5 rings of electrons and this guy has 5 rings of electrons. So it's not going to be the number of rings. They have the same number of rings. So who is larger? Well, the answer is strontium because strontium has a smaller effective nuclear charge. Strontium only has 38 protons in its nucleus, while tin has 50. 50 protons in its nucleus will attract the electrons way more, shrinking the atom relative to strontium. Strontium is larger and tin would be smaller radius. Okay, germanium or tin? So we'll do that one, and I want you to do, you do the rest of them, please. I'm gonna pause my lecture. Okay, so this is what I got. Tin is larger, it has more rings electrons, more shielding effect. It's below germanium. They're in the same family, but it's lower than it, which means it has more rings of electrons. Germanium is larger because germanium and bromine are in the same period, but germanium has a less effective nuclear charge which won't allow the atom to shrink as much. Chromium or tungsten. Tungsten and chromium are in the same family, but tungsten is lower on the periodic table. Further down, more rings of electrons, more shielding effect. Questions before we move on? All right.
I got a question.
Yep.
When did you stop recording?
While I was letting you practice. I'm back recording again.
Okay.
All right, so here's all the answers. Okay, we're going to rank now by increasing radii. So let's talk about what this word means. This means smallest to biggest, or largest, whatever. That's what the word increasing radii means. So you go on your periodic table. So carbon, oxygen, sulfur, hydrogen, nitrogen. Okay. I wish I could. So hydrogen, oops, carbon, oxygen, sulfur. Who was the other one? Was it nitrogen? Okay, so obviously hydrogen's the smallest. Hydrogen is the smallest. Smallest. It's on the first period, it has first ring. Who is the next smallest? Well, these guys are in the same period. Oxygen is the smallest of those in that period because it has the highest effective nuclear charge. Then nitrogen, then carbon, and then the biggest is sulfur because it is on the third energy level, so it has 3 rings of electrons. More shielding. So questions on that? Hey, what time is class over? What time does the bell ring? Anybody?
9:05.
9:05. Oh man. I'm gonna, you guys, it's all hybrid today, so I'm gonna finish one more thing and then I'll let you go. It's not too complicated. It kind of tags off of this. Okay. So ionic radius, we are going to focus on atoms gaining or losing electrons. That's the word ion means. Okay, you're either gaining or losing electrons. So look, I'm going to start with neutral lithium. Okay, so you have your 3, so it'll look like this. Okay, neutral lithium. Neutral lithium. All lithium, neutral lithiums have 3 electrons. That's what these dashed lines are, okay? All right, now, in order to rank them, if we're going to start removing or taking or gaining electrons, we're going to change the size of the radius. So lithium +1, what does the +1? +1 means you've lost 1 electron. And remember, you'll always lose electrons from the valence shell first. So like lithium, I'm going to get rid of this last electron. Well, what does my radius do now? I don't have any electrons now in this outermost shell, so my radius doesn't go out to there. My radius only goes to there, so it shrinks, okay? I now have a smaller radius than I did originally, okay? This is original lithium, so this is lithium neutral. Lithium neutral, okay? Now, this is harder to see, but lithium anion, meaning I'm going to gain 1 electron, so I'm going to throw this extra electron out here. Okay, there's this extra electron. And now it's hard to see this, but electrons and other electrons repel each other. So what are they going to do? They're going to move away from each other. Well, what does them moving away from each other mean? It means they're going to spread out a little bit more, right? They're going to want to be a little bit further away from each other, which then causes the radius to increase. Okay, let me just fix this little part right here. Oh, that's so big. So because electrons repel other electrons, okay, my radius is now this big. So an anion the normal element is going to be larger. So when I say that this is the anion is larger, it's larger than its neutral element. So these all were lithium, okay? So the cation of the lithium atom is the smallest and the anion of the lithium atom is the biggest, okay? So again, you have to kind of mess with electrons. So if we wanted to rank by increasing radii, and this is where I'm going to stop, we're going to rank these increasing radii. That means smallest to biggest. Okay, smallest to biggest. You go, okay, well, hydrogen's on the first period. So hydrogen, these 2 guys are going to be the smallest. Which one? Now, which one's smaller? The hydrogen cation or hydrogen? Well, we know if hydrogen loses 1 electron, it literally has no electrons anymore. So hydrogen cation is the smallest. And then the neutral hydrogen.
906.
I know. I'm just finishing up. So what about chlorine and the chloride ion? So chlorine is the next smallest and the chloride is the biggest because that extra electron in the valence shell causes repulsion, and repulsion will make the electrons want to move away from each other. Away causes something to expand. So I'm ending with ionic radius. You'll do your reading worksheet tonight, and I will see you guys tomorrow.
When are you going to post the notes?
The notes are already posted on Canvas on the homepage.
No, I meant like the video where you drew on it.
Oh, after I'm done teaching my other classes.
Okay.
It has to get published to YouTube.
Okay. Bye.
Bye. Have a good day.